Recovery yield. Recrystallization is a method of purification that we use for solid compounds, where we take a crude solid, we dissolve it in a suitable solvent, often at higher temperature. Then, as we allow it to cool down, the desired product will crystallize and all the impurities are expected to stay inside the solution. At that point, we could easily filter, wash, and dry our crystals, and we would find very pure material. In order to determine a recovery yield, we would look at the final product amount and divide it by the initial amount. So in our case, the mass of the crystallized product gets divided by the mass of the original crude sample. And because we want a yield or a percent yield type answer, we can consider it in this mathematical form. Recovery yield percent is mass of purified crystals obtained divided by the mass of crude solids to be crystallized times 100. We apply this concept to our recrystallization of cream of tartar experiment. We start the experiment with 25.00 grams of cream of tartar, and this may be a little different for you. We combine it with 450 milliliters of deionized water, and this could be a little more or a little less, and we heat it until it boils. When it's boiling, we will filter the solution to remove any undissolved impurities, and for that filtration, we may use hot filtration or Buchner filtration. Then the filtrate is going to be set aside to cool down, and in the solution, as it cools, we are going to observe the formation of crystals. Once those crystals are formed, they are going to be filtered, rinsed with cold or room temperature deionized water, and then left to air dry. The task here is to calculate the recovery yield for the crystallization process. First, we make some assumptions. The first is that only cream of tartar crystals are formed in the process. And the second assumption that we make is that when we record the mass of the cream of tartar crystals were completely dry. Then we simply apply the required expression. Mass of purified crystals obtained is 21.93 grams. Divided by mass of crude solid to be crystallized, 25.00 grams. The grams will cancel, and we multiply everything by 100 to get a percent value, 87.72%. That's a fairly high recovery yield. But let's see if we can determine how much we could actually get if we hadn't made any mistakes in the process. And that is what this question is asking for. Calculate the maximum amount of cream of tartar that could be obtained. Here we make some assumptions. First, we assume that the room temperature is 20 degrees and the boiling point of water, regardless if there's anything in it, is 100 degrees Celsius. If it is not so and we want to be more accurate in our measurements, we could easily place a thermometer inside the beaker before we start the heating process and at the time when we begin our filtration. And that will allow us to more accurately capture the temperature of our room and the temperature of our boiling solution. We also need some information in order to perform this calculation. First, we need to know the solubility of cream of tartar at our room temperature, or 20 degrees Celsius. And I looked this up. It is 0.57 grams per 100 milliliter of water. We'll also need to know the solubility of cream of tartar at the boiling point of water, which is 100 degrees Celsius, and we find that it is 6.1 grams per 100 milliliters of water. Now, you may use this information and reference this tutorial, or you may find a different source and reference that in your existing knowledge category. Step 1. Let's calculate the mass of the cream of tartar that could be dissolved if we just mix it with water and leave it at room temperature the whole time. For that, we're going to start with our volume of water. We're using 450 milliliters. And we use the solubility at 20 degrees Celsius, which told us that for every 100 milliliters of water, we will be able to dissolve 0.57 grams of cream of tartar, which is potassium hydrogen tartrate. To calculate the value, we'll simply plug it into our calculators and we find that it is 2.57 grams of the potassium bitartrate. In the next step, we're going to determine how much of the cream of tartar could be dissolved if we boiled our solution. So we need to do the same calculation with the solubility of cream of tartar at 100 degrees Celsius. We start with our amount of water, 450 milliliters of volume. And we know that for every 100 milliliters of water, we should be able to dissolve 6.1 grams of the cream of tartar. The number is 27.45 grams of cream of tartar. There's quite a bit of difference in the amount of potassium bitartrate or cream of tartar that we can dissolve at 20 degrees Celsius and at 100 degrees Celsius. If you place it at room temperature in water, you can stir it as much as you want. You can't exceed the solubility of the cream of tartar that is at 20 degrees. But if you heat it up, more and more cream of tartar will dissolve until at 100 degrees, 27.45 grams of cream of tartar could dissolve in the 450 milliliters of water. Now we're going to also assume that our water volume did not boil away at all. And at the end of the experiment, we still have 450 milliliters. If some of it boiled away, we would have to consider it separately. In our step 3, we need to look at the difference between what was dissolved at 100 degrees and what was dissolved at 20 degrees. We take the amount that was soluble at 100 degrees, 27.45 grams of cream of tartar, from which we subtract the amount of cream of tartar that would still be dissolved as the solution cooled down from boiling point to room temperature. And that is the 2.57 grams. The difference of these two is 24.88 grams of cream of tartar, which would have precipitated or would have crystallized as the temperature cooled down from 100 to 20 degrees Celsius. And then finally, what would be the theoretical recovery yield? We would take the same calculation. Recovery yield or recovery percent equals the mass of the crystallized product, which is what the amount of crystalline material we just calculated. It is the 24.88 grams of cream of tartar, divided by the initial amount, or in our case, if we dissolved the exact amount that would be soluble at 100 degrees, which is the 27.45 grams. Then we take this value and multiply it by 100. The grams will cancel, and we will end up with a percentage which is 90.6%. When we're working with large amounts, it is normal for the theoretical yield and the actual recovery yield to be relatively close. The more you scale down to micro scale, the more likely it is that experimental errors could cause larger and larger differences between your theoretical and actual recovery yields.